Hello and welcome to Bachelor of Physics. This is the example video for electrostatics and Coulomb's law. We have a lot of examples to get to, so let's jump right into it. So the first one, we have three charges, Q1, Q2, Q3, and they're kind of like in a triangle formation. We know Q1 has a magnitude of 2 mu c, or 2 microcoulombs, but we don't know the sign. We know Q3 has a charge of positive 4 microcoulombs, and we don't know the sign or value of Q2. And basically, we want to find the magnitude of Q2, and we also want to find F net. Now, F net is solely pointing in the left direction. So from there, we can find out the signs of each of the charges and later the magnitudes. So if the F net is pointing to the left, then the force being exerted from Q1 and Q2 need to push this positive charge to the left, and only to the left, not up or down, only to the left. Which means that if out of 4 possible arrangements, right, this one could be positive or negative, and this one can be positive or negative. Well, if this one is positive, then the force on Q3 is going to be up and to the right, and that's not what we want. So we kind of already know that Q1 is going to be negative. So, okay. Now Q2, we want it to push Q3 to the left, and if this is negative, if Q1 is negative, then it's going to be pulling it to the left and down. So we want Q2 to push Q3 up and to the left, which means Q2 is going to be a positive charge. Now we figured out the signs. Let's actually start solving for the magnitude of Q2. Well, how can we do that? Well, we know that the force on Q3 in the y directions from Q2 and Q1 should cancel out. So, Fy is equal to 0 is equal to, okay, so K, and we're not going to deal with theta issues. I'm just going to put negatives depending on the direction that they go. K Q1 Q3 over R1 squared is equal to, or I suppose minus K Q2 Q3. Oh, you know what? I'm forgetting. So we want this only in the y direction. So it's probably going to be, if we make a triangle here, we basically want this vector, this is phi, this is theta. And so we want cosine theta for Q1, but sine theta for Q1 minus K Q2 Q3 R2 squared cosine theta. Because again, we want the vector that's going up, and that's cosine theta. But here, it's a little bit different because this angle is phi and this angle is theta, and so sine theta is up. Okay, so we can get rid of K, and we can get rid of K3, and what we're left with is Q1 sine theta over R1 squared minus Q2 cosine theta R2 squared, which means that Q1 tan theta times R2 squared over R1 squared is equal to K2 or Q2, which is equal to 0.844 microcoulombs. And of course, we already know this is positive. Okay, so now we have the magnitude of Q2. Let's solve for F net. And we know it's only going to be going in the x direction. And so we can find F net by doing K, Q1, Q3, cosine theta R1 squared plus K, Q2, Q3 sine theta R2 squared. So let's see where that leads us. We're going to end up with K, Q3 times Q1 cosine theta over R1 squared plus Q2 sine theta over R2 squared. And if I remember correctly, this came out to be about 56 newtons. And the force is of course going to the left. This, if it was a vector, it would be a negative value. Okay. Now we're looking at a line charge along the axis, the x-axis, and we want to find the E field along the x-axis when x is greater than a, and we want to find the force. Okay, so dE is equal to K dQ over R squared. Actually, do we call it? Yeah, okay, we'll call it R squared. Okay, and then if you remember from linear charge density, we denote it as lambda. However, lambda is just charge over a distance, so we're going to do K and KQ over A times D. What do we do? Do we do dx? Or do we do... Yeah, let's do dx. No. Let's do dl. And then the distance is... Well, we want it to be greater than a, so we're going to do x minus l squared. This term is r, and we're doing x because it's going to be any point on the x-axis, and l, which represents the distance or the length of the rod, which we're integrating over. And now let's integrate for e. The integral, so e is equal to the integral from 0 to a. Oh, jeez, I forgot the constants here. KQA dl x minus l squared. We set u equal to x minus l du is equal to negative dl. And then we're going to have, it's equal to KQA from x to x minus a du over u squared, pull out a negative, which when we integrate, there's going to be a negative because this is going to be u to negative 1. So we pull out a negative, and we're going to be left with kq over a times x, 1 over x minus a minus 1 over x, which comes out to be equal to kq x minus a x, as far as I am aware. And so to get force, we would just multiply it by q. Force is equal to kq little q x minus a x. Did I do that right? X minus a x, x minus x, a positive cancel. Yes. And then also you can see the limit as x goes to infinity. Well, of this, we're going to get kqq over x squared. Okay, I hope you thought that was pretty neat. Moving on to the next problem, we want to find the x and y components of the electric field, I suppose, and then also the force being exerted on this charge, which we're going to call Q. And then we'll call this one big Q. Okay, so let's solve for the x component first. So dE x is equal to k dq over r squared times cosine, which in this case is delta over r. Okay. So now this is going to leave us with k q over a times delta, right? Times delta times dy over r cubed, and r we can find using Pythagorean Theorem, and r cubed in that whole denominator is going to come out to be y squared plus delta squared to the power of 3/2. Okay, because there's a square root, so this exponent is going to get divided by 2. So now we have to integrate. So e to the x, e sub x is equal to k q delta a from 0 to a dy y squared plus delta squared 3/2. We're going to have to use a trig sub. Y is equal to delta tan theta, dy is equal to delta secant squared theta d theta. Okay, oh geez, am I going to have enough room to do e sub y? I hope so, but maybe not. But we'll just write the integral over here. That's equal to kq delta a from 0 to arctan of a y. Okay. So now this becomes secant squared, which becomes secant cubed. Well, first we take out, so delta, 1 over delta cubed. Jeez. Okay. 1 over delta cube, 1 over delta squared. Delta squared. Cubed squared. Secant, so 1 over secant, which is just cosine. Cosine theta d theta. Jeez, I hope I haven't messed anything up so far. Which becomes kq delta a sine of arctan. Oof, disgusting. Let's see if we can draw that little triangle. So this is y squared plus delta squared. And this is delta. This is delta, and this is a, which means that the sine of this is a over square root y squared plus delta. Oh my gosh, okay. Oof, of a delta. So this is actually a, oh, sine, goodness gracious, okay. A over square root of a squared plus delta squared minus, is it going to be minus anything? Minus, I suppose it would be 0. So then it would just be minus a over delta. A over delta? No, it'd be 0. I think it'd just be 0 over delta, which is just 0. Okay, let's hope that's right. Let's hope that is right. And then we're going to get kq delta square root a squared plus delta squared. Okay, so now for the y component, okay. Y component, y kq over a dy times y squared plus delta squared 3/2. And we're going to use the same trig sub. So we're going to get EY is equal to KQ over A. Delta, so 2 theta 1, and we're going to get delta squared, so 1 over delta, and then secant cubed over secant, tan over secant, which is tan times square, which is just sine theta d theta. Okay, and now it's going to be cosine, or shall I say negative cosine, kq over a delta of negative, or we'll just pull a negative out, cosine, so that's delta over a squared plus delta squared plus delta over delta squared, which is just, or not plus, but rather minus 1. And then from there, I think I might just skip this part. So basically from here, you would use Pythagorean Theorem, you would do the square root of e sub y squared plus e sub x squared, and then you would get e, multiply that by q, and you get the force. And then from there, if you really want to find the force, the x and y components of force, then you can actually find similar triangles and such, find theta. But I mean, this is the important part. Okay, on to the next problem. Quick correction. This was supposed to start out as 90, or not as 90, as negative, which means this here would have been a positive. And the reason for this is because we're looking at E field going down towards the negative y-axis. And there's probably a trigonometric reason to this, but I haven't figured it out yet. But once I do figure it out, I will create an analysis video and talk about it. Okay, now for this one, line charge curved. Looking for the E field at the origin. This positive charge is causing an E field down to the right. This negative charge is causing an E field up to the right. These two are going to cancel out because it's the same distance, the same charge, except opposite. So EY is going to be 0. Now, DEX, KDQ1. Now, DQ1 is Q1 over pi over 2, right? From 0 to pi over 2, times A, which is, that's circumference, basically. You know, radius times theta. So we're going to have K2Q1 pi A. Now for R squared, R is a distance from the charge. However, the distance doesn't change. It's always going to be A. So we're just going to plug in for R. That's going to be times, we're looking for the x component, so we're doing cosine. We're doing cosine of, this here is theta, this is phi. So I'm actually going to do phi. D big R d theta plus K2Q2. It's basically going to be the same except Q2 cosine phi dr d theta. Okay, so now we have E of x 2k pi a cubed q1. Now our integral is going to be from 0 to pi over 2, and our first integral, and then this is our second integral, and the first integral is from 0 to a, or not sine theta, cosine theta, dr d theta plus q2 from pi over 2 to pi, 0 to a cosine theta dr d theta. When we integrate dr for both these integrals, it's going to go to a, so we can pull out an a. And then we're going to be left with the integral of cosine theta d theta from 0 to pi over 2. Integral of cosine theta sine theta of pi over 2. 1 minus sine 0 is 1. So we're going to have q1 because this goes to 1. This integral of cosine theta sine of pi is 0 minus pi over 2 is 1, or negative 1, except k2 is negative, so if we pulled out a negative, it will come out to be positive. And since they're the same, q1 is equal to negative q2, we can just pull out the negative and we're basically just going to get plus q1, which comes out to 4k q1 over pi squared. And the last problem is going to be an annulus problem. Okay, last but certainly not least, I hope you guys can tell how tired I am. Probably done like an hour of footage. Anyway, annulus. We want to find the E field along the x-axis. This annulus has charge density sigma. Alright, well, if we integrate along here, then like at some random point at x, right, like we're going to get an E field this way and this way. And the components that are canceling out here are in the y. So we're only going to have x. So we'll be multiplying, well, not only will we only be solving for d of ex, but we'll be multiplying by cosine theta as always. Okay, so k dq over r squared is equal to k sigma, for sigma is charge density, so that's charge over area. So we're not doing q over whatever. We're just gonna leave it as sigma, right? And then we're doing r dr d theta. As this is the differential for area. This is dA. It is dA. Okay, now these two I don't believe those cancel out. Oh, actually, because this r is actually in the y, right? This is x, this is y. So it's actually not r dr, rather it's y dy, and this r is this distance. Okay. Times cosine theta, which is going to be x over r. So now we have k sigma x. Yeah, no, that's not over anything. K sigma x double integral of y over r cubed, and r is y squared plus x squared. 3/2 dy d theta. And of course, we're going to be doing a lovely trig sub. Y is equal to x tan phi dy is equal to x secant squared phi d phi. Y times dy, we have x squared on top, x cubed. When we pull out an x squared here, we're going to get x cubed, so all the x's are going to go away. So we're going to be left with k sigma 0 to 2 pi theta 1 theta 2. I'll deal with that later. Secant squared on top, secant cubed on the bottom, which means we have secant on the bottom, which is cosine. Tangent on top, so what we're left with is sine phi d theta. And then we'll draw the triangle here. Okay, so actually I'm going to solve that second integral already. This second theta is not dependent on phi, so I'm gonna solve it right now. It's 2 pi. And now we're going from R1 to R2, so we have arctan sine phi d phi. Okay, and arctan, so this is going to become negative cosine. Is that right? Negative cosine. Yes. K sigma 2 pi cosine of arctan of R2 x x of R2 squared plus x squared minus x R1 squared plus x squared. And then if you really want to, you could pull out an x here, cancel these two out. But that is it. I mean, that, you know, these are like the hardest problems of this concept. So there you have it, folks. It's been a long day. Hope to see you in the next concept video.